In this video, we are going to present a multi-cloud machine learning workflow for collaboration between data scientists. This is Sarah on an AWS region, and her colleague James on a different AWS region. Sarah will download and pre-process a dataset using a Jupyter notebook. James will train the model using Sarah's pre-processed dataset. Finally, Sarah can use the trained model for inference. Step 1. Create environment. Ingress data. Pre-process data. This is the Rock UI, where Sarah can save her snapshots in buckets and share them with her colleagues. She goes to the Kubeflow dashboard, opens Jupyter, and logs in. She selects 2 CPUs and 8 GB of RAM. She also adds a new empty data volume, which is managed by Rock. Then she spawns the lab. Sarah opens a terminal and clones the Kubeflow examples repo. She also installs some libraries that she's going to need later. We can see that the data volume she added is currently empty. Sarah is now going to open a notebook and start working on it. She starts with downloading some data. We can see that the G data volume is no longer empty. It contains the data Sarah just downloaded and unzipped. Now, Sarah is going to take a snapshot of her whole environment using the Rock UI. She selects her bucket, clicks to register a new file, and chooses to register a whole lab. This is the Rock registration form. Sarah selects her Jupyter lab. She adds a commit title and a commit message. Accepts the suggested file name, and she takes the snapshot. A new task has been created for this snapshot. We can see the progress of the task. The task is completed. It took only 83 seconds. Going back to the notebook, Sarah is going to pre-process the data to make them ready for training. Pre-processing is done successfully. Now, she's gonna take a second snapshot, this time using the command line. With this command, she'll take a snapshot of her Jupyter lab and put it in her bucket called From A. She adds a commit title and commit message from the command line in a Git-like way. We can see that a new task has been created on the Rock UI. The task is completed. It took her only 20 seconds. Step 2. On a different AWS region, James is going to train the model using a small sample just to see that it works. This is James's distinct Rock UI. James and Sarah have already 2 connected buckets. They can share snapshots in a Dropbox-like way. He finds the latest snapshot Sarah took, and he's going to use it to create the exact same environment Sarah had on location A. He copies the Rock URL link that corresponds to this snapshot. He switches to the Kubeflow UI. Then he logs in to his Jupyter lab and uses the Rock URL to create a Jupyter lab identical to Sarah's. We see that the form gets autofilled. His lab is going to have all the installed libraries, the downloaded data, and the pre-processed data. We can see that all data is already there. Now, James is going to train the model using a small sample. Finally, he takes a snapshot of his lab using the command line and puts the snapshot in his bucket, named From B. He provides a commit title and a commit message. We can see that a new task has been created on the Rock UI. The task is completed. It took him only 28 seconds to take the snapshot. Step 3. This time, James is going to spawn a TF job to train the model using a larger sample. He copies the Rock URL of the previous snapshot and gives it as a name to a variable called snapshot. Now, He's going to train the model using a larger sample by spawning a TF job and using the same Python code he used previously. We can see that an error occurred. James had to provide the snapshot's rock URL to spawn the TF job. He tries again, providing the corresponding snapshot's rock URL. We can see the two PVCs that are going to be created: their name, their origin, which is a rock URL, and their mount points. He doesn't need to modify anything here. We can see that a TF job has been created. Let's see the logs of the corresponding pod. We see the training of the model. Training ended successfully. Now, James will go to the Rock UI and take a snapshot of the trained model. He won't snapshot the whole lab this time, just the final model. He finds the corresponding PVC and provides a commit title and commit message for this snapshot. He also changes the file name to something he prefers. We can see that a new task has been created. The task is completed. It took only 30 seconds. Step 4. Finally, Sarah on location A is going to run inference locally using the model trained on location B by James. To do so, she spawns the Jupyter lab that she created in the first place. She will also add a data volume containing the trained model, the one that James trained previously. She goes to the Rock UI, finds her bucket, and copies the rock URL of her lab. She uses the URL to recreate her lab. She's also going to add a second data volume. She goes back to the rock UI, finds the bucket that James is sharing with her, and copies the rock URL of the snapshot of the trained model. She provides the URL and gives a name to the new data volume. This data volume will contain the trained model. Then she spawns the lab. We can see that the first data volume, called gdata, contains all the data that Sarah created previously, while the second data volume, called gdata2, contains all the files that resulted from the training James performed. Now, Sarah, or another user on a different location, can use this model for inference, more experimentation, or further collaboration with other team members. Rock paired with Kubeflow enables users to share entire data science environments, including data, across teams and locations, empowering faster and easier collaboration among them. Now, data scientists can have a unified end-to-end machine learning workflow that spans hybrid and multi-cloud environments. Welcome to a new era of machine learning. powered by Arrikto. Thanks for watching.